So, for the next step,
You're gonna unplug your headphones, so my voice is gonna be playing in the back of your video then?
Hey everyone, welcome back to yet another video. This one's kind of special because we're looking at a chromium 2 compound. Now, chromium chemistry is normally fairly exciting, but this one's exciting for, a different reason apart from the normal, oxidizers, fires, explosions, stuff like that. This compound is interesting, and said compound being chromium 2 acetate, because it has a quadruple bond. Now, normally in chemistry you have single and double bonds. Those are pretty common, and rarely you get, the occasional triple bond. You really never get a quadruple bond. In this case, it's between two chromium atoms. It also happens in a, can't remember if it's a ruthenium or rhodium complex, but one of those. It's a really expensive element. Anyway, it's a really interesting bond, and there are only a few compounds that I know of that have it. And today, we're going to prepare one of those, chromium 2 acetate. There's a little bit of a catch, though, with chromium 2 compounds in that they are extremely air sensitive. I'm not saying like they're pyrophoric or they're going to blow up in your face if you put them in oxygen or anything like that. They just really don't like to be around oxygen because, being a chromium 2 compound, they can be really easily oxidized to chromium 3 by oxygen in the air. So what we can do to prevent this is eliminate the problem of oxygen entirely, and that's why I've made this setup right here. So let me get to that in just a sec. First, I'm going to focus on these three things right here. On the left, I have some rather crappy zinc metal. In the middle, I have a fairly strong solution of sodium acetate. And then, on the right, I have chromium metal. This is electrolytic grade. You need to have electrolytic grade, otherwise this will not work. And over here, this is really what makes this work. This is, well, a bowl filled with water, about a centimeter or two. In here I have one beaker on top of the other. This beaker right here is filled with probably about 20 milliliters or so of concentrated 31.45% hydrochloric acid. When I put this beaker over this and put the chromium in, it'll start generating hydrogen gas and make chromium 3 chloride. That will make a acidic solution of chromium 3 chloride, which then we can add the zinc to, which will reduce the chromium 3 chloride down to chromium 2 chloride, and then we can add sodium acetate to that, and we can see the nice red color of the chromium acetate, chromium 2 acetate, with the quadruple bond. So, let's get started. Enough talk. So, first, we're going to want to add some electrolytic chromium to the hydrochloric acid. This should not really start reacting right away. It'll take it a while. So, and plus you don't really have to worry with, especially with a setup like this, because if it does somehow spill over, it just goes into the water anyway. But I've never really had it spill over, so I really wouldn't say worry about that, but do keep it at the back of your mind that that is a possibility. So, without basically keeping you guys any longer, we can start to see some air being displaced. Let's just go ahead and wait for this reaction to finish, and then we can go ahead and continue on to the next step, which is reducing the chromium 3 to chromium 2. so that's probably about good. I'm going to go ahead and fish out the chromium. So what we have here is a solution of chromium 3 chloride in hydrochloric acid. What we can do now is add enough zinc to reduce the chromium 3 back to chromium 2. Watch out, this will make a lot of hydrogen. Actually, I should not put in such a large piece. A smaller one should do fine. Quickly cover it. As you can see, there's a lot more hydrogen coming off. No, obviously, just that little bit of zinc isn't going to be enough. Until you see a nice, deep blue color, about as deep as that. It looks black on camera. This is a really concentrated chromium 2 solution. You want it to look about this dark. Right here. So keep adding zinc until it's about this, well, blue. At least it looks blue to me. So yeah. I should mention, it is alright if you do lift up the beaker quickly and then, drop in a little bit of zinc and then cover it back up again. That won't really oxidize the chromium to any appreciable amount. As you can start to see now, it's looking nice and blue. I'm just going to add a little bit more zinc, and then we can go ahead and filter, and then see our complex. Alright, that's good enough. So what we can do now is go ahead and filter this to obtain a chromium 2 chloride solution. Nice and blue. Wow. Okay, work quickly from here and add this filtrate to your sodium acetate solution to see, or observe, the chromium 2 acetate complex, including quadruple bond, excuse me, and all of its red color. So let's do that. Here we go.
Jackpot!
There you can see the precipitation of the chromium 2 acetate as a lovely maroon solid. What you can do from here is filter it and then watch it as it slowly dies in front of you, or you can store it in a bottle and watch it die an even slower death. Well, up to you. Anyway, it's a really interesting compound which has some use in organic chemistry, I guess. I mean, it's something special, I guess. And just kind of a short, stupid video to show you. Alright, thanks for watching. You can like if you want to, subscribe if you want to. I'll catch you guys later. Next one should be a complex video. Bye. Psych, motherfuckers! You thought... Nah, we still gotta filter all this shit. Ooh. Very nice. And watch as absolutely none of it makes through the filter. Finna kill myself. Look at that. That's awful.